Okay, great. Welcome to my presentation. My name is Marian Varga, and I want to draw your attention to this link here that leads to a form, my contact form, where you can register, and it can be useful to you for two reasons. The first reason is you can get a free bonus. When I was preparing for this talk, I went through a lot of resources, collected a lot of material, made a lot of notes, but I won't present all of that because that would make the presentation very long and hard to follow. But what I did, I put it all together to some kind of an ebook. And so if you ask for it via that form, I will send it to you. And the second reason why this link can be useful is many times, firstly, I am very happy to be here with you in person, with professionals who are interested in learning more. And I encourage you to interrupt me with questions and comments. But it always happens that some questions pop up after the event, or new ideas come up after the event, and it's quite a pity that we cannot continue the conversation. So if you register, you will stay in touch with me, and I can also send you some updates about other stuff that I'm working on. I like to connect. You may know that I'm writing a book about connecting systems via APIs, but that's just one way of connecting systems. I believe Kotlin is also a tool that can help you connect legacy systems, old code, with new technology, new ways of developing software. And I also like connecting people because most of the software development is teamwork, and there are different people in different roles that need to work together, and it's important that they communicate effectively so they understand each other. And in this talk, I'm also trying to help connect the Java community with the Kotlin community. And basically, but why I'm doing it, it sounds like I'm trying to sell you something, right? And actually I am, because every time you say something in public, you're basically selling your ideas, your opinions. And to explain what got me here, I will tell you my story. I am, and I think I will always be, a Java guy. I started programming in Java when it was still at version 1.0 something, still during my study. Then since my first full-time job, I've always, throughout my whole career, I've always done something connected to Java or Java ecosystem. Then in 2016, I started in a team that developed a family of products that involved a lot of Android development. But interestingly enough, 2016 is also the year when the first version of Kotlin was released, but at that time I didn't know about it. In 2016 it was quite normal to write Android applications in Java. However, it wasn't the same Java I knew from the backend development, because Android has its own compiler and its own runtime. And that limited the Java that could be used to the syntax from Java 6. although at that time already Java 8 was available. And then in 2017, 2018, when I was looking at some Android code samples, I saw they were written in some language that I didn't know, and I found out it was Kotlin. Basically, what Google did, they decided they didn't want to switch from that Java 6 syntax to Java 8 and then maybe to some next version and next version. Instead, they decided to switch to a completely different language. Okay. Then in 2019, I switched projects again and I concentrated on the backend again. But it was a backend written in Spring Boot. But interestingly enough, it wasn't written in Kotlin. So I thought to myself, maybe this Kotlin thing is not just some Google extravaganza that they're trying to force all the world to use. Maybe it's something broader. And so I had to learn the language. That took me a few weeks. Then it took a few pull requests and code reviews from my teammates where I learned that I should avoid some Javaisms so that I write really nice idiomatic Kotlin code. And that was it. And I was productive really quick. And in the process, I fell in love with the language actually. Then when I left that project, I had to face the reality. Here you can see the developer survey from Stack Overflow that shows us that Kotlin is much smaller than Java. Java is much more popular. At the same time, we can also look it from a brighter side. If we compare Kotlin to other JVM languages, we can see that, for example, Groovy and Scala that have been around for longer are already overtaken by Kotlin, and Kotlin is actually an important player on the market. Okay, and so I still use Kotlin for my hobby projects. But for the customer projects, I came back to Java. But I also found out that there are new versions of Java coming, and they are bringing some syntax improvements that resemble some things that I already knew from Kotlin. So I started to be very eager in using these new versions. One customer, I created a skeleton of a new application that was based on Java 17. Then later I found out that their infrastructure is not ready for Java 17, so I had to downgrade to Java 11. Now the current LTS version is Java 21, but again, in many projects you can see that the upgrades are lagging behind, so many customers are missing out on, for example, virtual threads. Another thing that I realized over recent years is the older, or actually the more senior I get, the more I realize that the biggest problems in software development are actually not the technical ones, but the people problems, the lack of communication. And so I thought maybe one of the reasons why Kotlin is not used as much as it would deserve is that people basically don't know enough. They lack some information and education, and that's why I decided to help developers, managers architects to consider Kotlin and maybe decide to use it. If you have kids, you may have seen this image. This kid says, "I don't like this food." And I ask, "But have you tried it at least?" And she says, "No, but I know I won't like it." So the point is, if you haven't tried something, it's hard to tell if you really like it or if it's useful for you. So what I'm going to do is to let you taste a few bites of Kotlin. But before that, I would like to address those people that don't actually code. Do we have here anybody who in his job the most of the time doesn't spend writing or reviewing code but doing some other activities? No? Yes. Okay, okay. Yeah, but for the others, you definitely, I think you must meet such people in your projects, in your work. You have to work with them. And so what I'm going to tell you, you should pass it on, and that could also help you and them as well. These non-coder type of guys, what they care about are deadlines and budgets. So what do we need to meet the deadlines and fit into the budgets? We need efficiency, productivity. What's often forgotten is we want it long term, because if for some period of time you are delivering a lot of features, a lot of lines of code, then it doesn't really help you if later you find out that you also deliver a lot of defects. And if you get to your code gets so messy that adding a new feature means breaking the existing ones. So we need to do something to achieve the long-term efficiency. And I think one of the factors, or two of the factors, are code quality and motivated developers. Yeah, to the motivation, of course, the developers want to do fun things, and fiddling with some spaghetti code and trying to understand what it actually does and how to change it without breaking everything is not fun, right? And now let me ask you, what do you think quality code looks like? Any idea?
Easy to understand it.
Easy to understand? Readable?
Readable.
Tested. Okay. Yeah. Any more ideas?
Easy to maintain.
Solid. Whatever. Yeah. Okay, I mentioned solid because that's a common interview question. One thing that's often forgotten about Solid is that it's designed for object-oriented programming, and today we also have other ways to write programs, not just object-oriented. Okay, from my point of view, quality code is usually short, or at least it's not longer than necessary, and still it's expressive. So when you look at it, you know what it's trying to do. Or in other words, it has a high signal over noise ratio. To demonstrate what it means, let's take an example of a typical Java Pojo or Java Bean. So here the signal, the useful information, is in this blue rectangle, and all the rest is actually noise. That's just code that we ignore because it doesn't bring us any information. And so we also call it boilerplate code. And now you must be thinking, with my knowledge of Java, I must know there are records in Java, right? Yes, I know it. And we've had them since Java 14 actually. And that was actually the motivation why I wanted to go to Java 17 LTS, because Java record is very, very similar to what Kotlin calls data class. Well, okay, problem solved, right? I don't think so. Do you know of any use case where you cannot just simply switch that Pojo for record? Hibernate, yeah. Anything else?
Serialization.
Serialization. Maybe I don't do much serialization. I mean the Java serialization, or you mean Jackson?
Yes, Jackson, for example, you need no arcs constructor.
I think that's not really, doesn't have to be like that. I used Jackson with records and it worked quite well. Okay, there may be some special cases, but let's take a look. Okay, the first obvious thing that can be a problem is if you are still using an old Java that doesn't have records, right? But okay, let's keep that. You should definitely upgrade if you have such an old Java. Another thing, as we heard, Hibernate. If you use Hibernate, you need to have a mutable object, and records are immutable, which is good. Wherever you can, you should use immutable structures, but of course there are situations where you need something that is mutable, and with records you cannot have it. Another thing is, if you want to write Spring Bean, Spring needs to create subclasses from your class that are the proxy classes, and record is final, so you cannot extend it. So what can we do? And another nasty thing is if we mix records with the classic classes, we keep thinking, okay, if I need to read the first name, should I use get first name or just first name? Okay, just small thing, but also not nice. And then we have something called Lombok. How many of you don't use any Lombok on your Java projects? Why?
It's not wanted specifically by client.
Not wanted by the client. What does the client know about Lombok? Something that we don't know? Okay, let me tell you my view. Lombok is a annotation processor, similar to, for example, Matstruct, but it is different from Matstruct because with Matstruct you write an interface, and the Matstruct generates an implementation of that interface that is a separate class. With Lombok, you write an incomplete class, and Lombok adds that nasty boilerplate code in place, which means the bytecode that you get for that class actually doesn't match the source code that you write. So any tools that you use have to be prepared for that. They have to support it. Another thing is that you're actually introducing double dependency, because now to convert your source code to the bytecode, you depend on a particular version of Java and you depend on a particular version of Lombok. And actually, you may know that adding a dependency basically multiplies the number of all the combinations of how your code can be built, and also increases the chances that something will break. How is it with Kotlin? With Kotlin, instead of a data class, we can say we just want to have a normal class, and we can make it open, that's something that you need to do to make the class extendable. And that's it. And if you need to mutate something, instead of val, which means a value, which is immutable, you say it's a var, which means variable, so it's mutable. And you still have the same concise and consistent syntax. Okay, but even if you can use Java records, it is quite common that you have quite a lot of fields in the record. And here we have just 4 fields, and already the IDE is trying to be really very helpful and is adding us these hints so that we know what we are actually passing to the constructor. Here I can see I made a typo, actually, last name with double A, wow. So you have to write the arguments in the correct order, and if you make some changes, it's really easy to make a mistake. With Kotlin, you can do it the same way, just ordering the arguments, but what you also have available is named arguments. That means you specify what argument you are sending, and then you don't have to preserve the order. So it's much safer, much more readable, even without IDE. Another thing, as I said, immutability is a good thing, but when you need to make a change, when you need to modify one field, you need to make a new instance of the record or of the object, and this is not nice. You need to repeat all the fields that you are not interested in. With Kotlin, you have this copy constructor where you only specify the fields that you want to change, and that's it. Another nice thing is for the argument of constructor or method, you can define default values. So here I don't need to send the signum, and by default it will get the value of 1. So again, in Java you would have to write overloaded methods and pass the arguments from one overloaded method to another one, and again that's like boilerplate code that is easy to break, easy to make mistakes. Hard to read. Yeah. Okay, one thing that I liked about Java when I started using it was that this principle that it made the common things easy and the uncommon things possible. So in the 90s, a language with garbage collector, where basically the memory was managed for you, language that supported the national characters of all the languages, built-in threads, TCP/IP working even in Windows. That was a great thing in the 90s. And yeah, so those were all great things, that you got for free basically, and also the assumption that the way we want to write programs is the object-oriented programming. What's worse is that what's common changes in time. So I must say that I'm actually not fair to Java, because Kotlin is 20 years younger than Kotlin. So, and that gives it a great advantage. So the other way of writing code that is quite popular nowadays is the functional programming style. That's something that was added to Java in its version 8, but of course it had to be added so that it's backward compatible. And by the way, even Java is not 100% backwards compatible. I mean, the syntax. Underscore was usable as a normal variable name before Java 8. Then in Java 8 it was deprecated, in Java 9 it was forbidden, and it's been forbidden until now, Java 22. In Java 22, the underscore means unnamed variable, so you can use it in lambdas or in record patterns as a placeholder for those arguments that you're not interested in, and you can have them like 2 or 3, and there's no name clash because it's unnamed variable and you can't read from it. How does it work with function programming in Kotlin? First, let's talk about Java. If you have like a pure function, which is something that just takes some inputs and only based on the inputs produces some output, in Java it's called a static method. A static method has to be a member of a class. So this is typical for utility classes, that you have some reusable functions, and now you have to think, okay, does this function already exist? If it exists, is it in util, utils, helper? What's the name of the class? And if I want to create it again, what class should I put it in? And this is wasting time on something that we are not really interested in, because what we want to do is to write a function, right? With Kotlin, you can define functions on the top level, but you don't have to. You can hide them, you can make them private and just visible within some scope. Another cool thing that you can do is you can add functions to existing classes that are completely out of your control, like string, and then you can invoke that function as if it was a method of that class. This may be also dangerous, of course, so you could get into some clashes. That's maybe a case where I would consider defining it not on top level, but within some scope, but that depends. And again, functions come from algebra, right? And so many times a function is basically just an evaluation of an expression. So why do we need curly braces and return? In Kotlin, you can use this very nice syntax and you just write an expression and you have a function defined. Another sign of functional stream programming, data-driven programming, are these pipelines with map and filter and so on. In Java, you almost always start with stream. You need to get a stream from a collection, then you do something with it, and at the end you do collect again to some collection. In Kotlin, these operators like filter, map, and so on are built in the collection interface. So you don't need that uninteresting stuff, because I think 95% cases you just need to do something with the collection and get a collection back. Another interesting thing is these filter or map and other similar functions. They are called second order functions. That means their argument is again a function, usually a lambda expression. In Kotlin, if you have such a function that takes just one argument and that argument is a function, you don't have to write these round brackets. You just start the lambda, which in Kotlin is written in the curly braces, and you don't even have to specify the arguments of the lambda, and then you get the implicit argument that's called it, and this makes a really nice code that is easy to read and you understand what it actually does. Immutability is something that goes hand in hand with functional programming. So, of course, typically we want an immutable collection, like a list of some values. In Kotlin, the immutable collections are totally separated from the mutable collections at the compile time. So if you make a list of, because in Java you also have list of, but then you still can do add. In Kotlin you cannot do that. It will give you a compile time error, because Kotlin knows this is an immutable collection, so you cannot add to it. And of course you can also create mutable collections if you need them. In Java you have to specify the implementation, like array list. In Kotlin takes another approach. You just say, I want a mutable list, and I don't care about the implementation, because that's what happens 90% or 99% cases. It selects the implementation based on the number of elements. Of course, in Kotlin you can use everything that you can use in Java. So if you really want, you can specify array list, but I don't think you will want it. Now you may have heard about the so-called billion-dollar mistake. That's something that happened long ago in 1965. And through some languages, it got to Java as well. Basically, it's about allowing null as a value for reference types. So everything except primitive types can have a null value in Java, and then we get these famous null pointer exceptions that we love so much. And of course there are some mitigations. We have the optional class, but maybe you shouldn't use optional anywhere or everywhere. You should only use it for return values from functions. There are some sources about that. I don't want to go into details. We also have the various annotations, non-null, nullable, whatever, but they depend on some particular libraries that support them. So all these solutions are just partial, because even if you're returning an optional, Java doesn't prevent you to return null. Okay. And you get null pointer exception where you wouldn't expect it at all, because it's an optional, right? And in Java, in Kotlin, this null safety is built into the language. That means normal types are considered non-nullable, and if you want to make them nullable, you have to explicitly add this question mark. And now that it's nullable, I cannot just invoke replace on this string because it could be null, right? So it gives me a syntax error. If I want to fix that syntax error, I can use, for example, this operator question mark dot, and that will handle the null for me so that if it's null, then it won't try to evaluate the right-hand side of the operator. It will just stop and return null. So that's really nice and solves a lot of common cases. Now, I mentioned Java 21 and virtual threads, which is a nice feature of Java. But again, if you start playing with concurrency, you can get into trouble if you don't do it well. And there is something that should improve it. That's called structured concurrency. Unfortunately, still in Java 22, it's just in preview. In Kotlin, the structured concurrency is built into the language from the very start. It's called coroutines, and okay, maybe it's a little bit advanced, but if you really need to play with concurrency, basically structured concurrency is about solving the problem that when you start multiple threads, you want to make sure that you still have them all under control. So if one of the threads stops or fails, gets into some error state, you want to make sure that you don't lose control of the other ones and that all of them are finished, and then you can handle the errors or do whatever, but you don't get some loose threads that can do some unpredictable stuff. So
note, it's not building its library.
In Kotlin?
The suspend function is building.
Okay. Yeah, but yeah, there is a huge syntax support for it. Yeah, to be more precise. Okay, and I can tell you more and more examples, code examples, but I want to fit into the time. I will just skip through the other examples very quickly. For example, generic types in Java, again, something that was added in version 5, but there's a type erasure that causes some problems sometimes, and in Kotlin you have redefined functions which can help you in many cases to write nicer code. Again, what more? Primitive types. Primitive types feel really like a low level, and Kotlin decided to just not have them. So even the number 7 works the same as an object. You can call toString on it directly, but if you compile to the right code, the primitives will be used where it's possible. Operator overloading, infix operators. If you work with finance, you need to work with big decimal a lot, and if the expression looks like math and not like assembly, it's very helpful, I would say. Then, nullability. There are many ways how you can work with it. There are so-called scope functions that can help you a lot. String interpolation, again, something that's coming to Java, but still it's in preview, and due to backward compatibility, it is a little bit strange. Maybe it will be better than in Kotlin, I don't know, but it's still in preview. Destructuring, you can work on many things, not just records or data classes. You can for example, take an array or a list and take just and take a list of variables from it. No checked exceptions. Checked checked exceptions in Java are not very nice to work with, and even Java basically admits it by having an unchecked IO exception in it. So guess why it is there. So there are many syntax advantages of Kotlin, and still many say this is just a syntax sugar. It's not worth to use a language just for syntax. Yeah, but if you combine so many improvements in syntax, you get the synergic effect, and I think the result is so powerful that it really is more than just the sum of the parts. Then even in Java, the new versions as they are coming, they bring improvements in the syntax, but there are some people, some Java programmers who just ignore them and they say, okay, why do I need that? For that, I would say maybe it's because they are coming in these small bits. If you get just a small improvement, you say, okay, it's not worth bothering. I'll continue how I worked forever. But once at a conference, I actually was arguing with the presenter who said, I said, okay, I like virtual threads in Java 21 because you just you don't need to change almost anything in your code. You just activate it and you get benefits. And he said, no, the syntax improvements are important because they make you think differently about the code. And actually, it is probably true that it's like even if you learn natural languages, if you learn, I learned Portuguese, I like Hungarian. Every language expresses things differently and it makes you think differently. And I think that's very important. That can help you do things better. And again, okay, even these guys who ignore the upgrades in Java, at some point they do the upgrade, then suddenly it's a lot of changes at once, a lot, not just syntax changes, but also changes in dependencies, frameworks, and so on. And then it's hard and people are avoiding it. So basically, I'm too busy chopping wood and I cannot sharpen my axe. Well, what to do? You are losing the fun of it. Okay. Do you see any issues with? Could you start using Kotlin today, tomorrow? What comes to your mind? Would you try it in your work, in your project? What do you think? Silence. Okay, maybe I'll help you. I know many arguments. First, yeah, of course it's a different language, so yeah, it can be hard. But really, Kotlin was designed to make the transition and interoperability with Java very, very smooth. So you can call really anything from Java code from Kotlin. You can extend classes and vice versa. Actually, it is almost like when you have a code base where you mix older Java syntax with newer Java syntax. Okay, not totally, but very close to it. So, and actually you have an advantage that with Java, if you want to use these new syntax features, you have to switch to new JVM. Whereas with Kotlin, you don't have to, because Kotlin compiles the old Kotlin code to bytecode, and the current version of Kotlin supports from Java 8. The older versions of Kotlin were able to generate bytecode for Java 6 even. So it adds you like an additional layer that you can set you free from the JVM dependency. And yeah, IntelliJ IDEA can translate Java to Kotlin automatically. The code is not like perfect. You need to make some manual changes, but it also can speed up the transition a lot. Then, of course, you must ask, okay, I have some frameworks that I use. What do I do with Kotlin? But actually, the frameworks think about Kotlin programmers a lot. If you look at Spring Initializer, it will allow you to generate Kotlin projects. Even if you use Gradle, the Gradle build can be written in Kotlin. And if you look at the documentation, you can switch to Kotlin and you will see the examples in the Kotlin syntax, so you don't have to, break your head thinking about how it will look like in Kotlin. And of course, then your manager comes and says, yeah, but there are so many Java programmers on the market. How do I get these Kotlin programmers? So, well, maybe it's not so bad that there are fewer Kotlin programmers than Java programmers, because if you at least mention in your job description that you work with Kotlin, it can help you basically filter those people that care about quality, who know that the signal over noise ratio is important, and people who want to learn new things, not just Kotlin, maybe also other things, and you know that in every project you need to learn new things. And then you can also hunt for programmers that are outside of the JVM world. For example, Android programmers who want to become full stack, or maybe some young guys who look at Java like, oh, it's a legacy old thing, I don't want to use that, but Kotlin is much cooler, so that can be attractive to them. And basically the easiest way is to just hire Java programmers and let them learn Kotlin. That was my case. I didn't learn Kotlin when I joined that Kotlin project, and I was really productive in a short time. You usually spend a longer time learning the business domain than learning Kotlin if you already know Java. Then, of course, you don't have to switch all in. You can start with code that is not in production, like some tools. You can use it for testing. You can write unit tests, integration tests with Kotlin. And actually, for tests, it's especially nice because in tests there is a lot of boilerplate code usually. And the problem with tests is usually it's hard to make people maintain them. And it's hard to read what does the test actually do, and how should I adjust it. Now the test is broken again. I don't know. I don't understand. I will delete the test rather than trying to fix it. So also again, better syntax can basically improve your test coverage maybe. And here are just some small, again, examples of the syntax. With Kotlin, you can use these backticks, and then you can use basically any string as an identifier. And for tests, it's nice because you can name the tests with a human readable name, and that can also help a lot. Extension functions again for generating test data in the format that you need. That can also be very nice. Okay, now I'm almost finished, but before I really finish, I want to tell you something also about Kotlin beyond just backend. A second principle that I liked about Java when I started with it is this write once, run anywhere. As I said, okay, having a GUI program that ran on Unix and on Windows in the 90s, that was really a crazy thing. Now, and actually, what was the programs that I wrote when in the 90s when I was studying? They were Java applets. I don't know if you know what Java applets were. Basically, they were Java programs that ran in the browser, web browser. Now, no browser supports Java applets anymore. Of course, we know that all the interactive stuff in web browsers is programmed in JavaScript. But with Kotlin, you can transcompile to JavaScript. So you can write programs that run in the browser. And not just that, actually currently the most development of Kotlin goes into the direction of Kotlin multi-platform. And you can get, of course, Android, also iOS, native applications, and that includes UI. So there's this Compose framework, and with it you can have a consistent UI that runs on these different platforms, even on a desktop and native. Also, you can get native code that is smaller than, if you know GraalVM, can generate native code from Java, but from Kotlin it's smaller, and this might be interesting if you need to program for small devices with low resources, so for some embedded systems. And the new cool thing is WebAssembly, and not just for the web. Many people predict actually that it will replace Docker containers in the future, because if you need to just deploy a backend service, you don't really need Linux operating system for it. You just need some safe place where it can run your code, right? So that's also possible with Kotlin, and you can completely skip the JVM. And one more idea for your head: as a backend developer with Java, you know that for front end JavaScript is used. JavaScript basically was created also in the 90s, in a very similar way as Java, but now it dominated the browser space, the client side of the web applications. And those guys already also learned that for large-scale projects, it's a good idea to have a statically typed language. So TypeScript was invented, and of course you can run JavaScript or TypeScript on the backend as well. We have Node.js, so and with agile development, actually it's quite popular to have full-stack developers, because then you can split your work by business features, and the developer can do the front end and the back end, and you don't have to split it into two separate tasks done by two separate people who need to coordinate. It gets into different sprints, and problems, especially from the product owner point of view. So the idea is, do you want to learn TypeScript? I think it would be much nicer to learn Kotlin and have the possibility to grow from the back end to full stack in that way. And even if I didn't convince you at all, you can return to Java like I did. But after trying Kotlin, at least, you will look at Java with new eyes. You will understand what the new features of Java are about, why they are so important or interesting, and you will not maybe forget to upgrade as soon as possible. And that's it. Again, the link. If you have any questions, feel free to ask, or we can discuss later. Yeah?
What do you think is the biggest downside using Kotlin?
Okay, that's basically in that bonus that you can download, but I can tell you biggest downside. Okay, I mentioned something about that you need to build the team, of course, and persuade the management and so on. But another thing is, for example, this interoperability with Java. It has some limits because, of course, if you call code from Java, the Kotlin makes some assumptions that for example, a reference type is not nullable. And if it's because if it made everything from Java like this question mark type, that wouldn't be very nice. That would be again would lead to boilerplate code or not very nice code. But it can happen that actually that Java code will return you null, and if you don't explicitly say that it's nullable, then you will get null pointer exception even in Kotlin. That's one disadvantage. What more? There are some, of course, some features that exist in Kotlin doesn't exist in Java, like for example the top level functions. So Kotlin has to generate some synthetic classes so that it can be represented in bytecode somehow. So sometimes from Java the Kotlin code can look a little bit strange, but it's not a big deal. It's usually quite understandable. And yeah, for me, very personal thing, but it happens to many people who switch between Java and Kotlin. In Kotlin, the type is written after the variable name. In Java, you first write the type and then the variable name. And of course, you keep confusing it if you switch between Java and Kotlin, but that's only a minor thing because the compiler will shout at you very soon. I don't know what more.
Can you use anything else than IntelliJ?
Yeah, that's true. Also, the IDE support is mostly the JetBrains. But I think even Java programmers, a vast majority of them use IntelliJ IDEA currently. Yeah, maybe there are some people who use Eclipse or something else, but yeah, maybe it will come also to some other IDEs. But yeah, that's also some kind of a limitation. Okay.
You are currently not using Kotlin on the project?
Not for customers. I only use it for a hobby project. Yeah. So yeah, that's why I'm trying to educate people to not be scared about it and try it.
And why not for customers?
Well, as I said, it's a long process, and especially if you're on a big project where you have a lot of teams, then of course if everybody's using Kotlin, Java, then it's not easy, and you also need to have support from like build pipelines, for example, if you have centralized build pipelines. But actually, in previous job, previous project, there were teams. We had teams that used Java, and we had teams that used Kotlin. So it was like more free, and yeah, most of the teams used Java, but there were some brave guys who used Kotlin.
Because I'm thinking that I heard so many times about Kotlin, but I've never tried it. And actually now I'm thinking that if I can just type Kotlin code inside Java code and it works, or do I have to do something more?
You have to do more. You have to at least add the Kotlin library into your dependencies, and it's probably a good practice to have a separate directory. Like if you use Maven, you have this source Java, and you can have source Kotlin. But yeah, it's not too complicated to really start. Of course, okay. Another thing where it's probably not recommended to switch to Kotlin if you have really a legacy project that is in maintenance mode only, where you only make really small changes, then it probably doesn't make sense to switch it to Kotlin, because that wouldn't pay off. But if it's still in active development, you are adding features, then every class that you touch, you convert to Kotlin. It's quite doable.
I think that would be great if I could just try it and write it and suddenly, oh, it works.
Or as I said, you can start with some nice tests, or some,
even then, for example,
some
if I
tools,
could...
some converters, whatever, and just to demonstrate, to do some POC that okay, see what a nice code, and it does what we need.
It's like a bigger step. If I could go tomorrow to work and I just try some test writing Kotlin and oh, it works. Oh, why we are not doing it like this? That would be nice.
Okay, more questions? Yeah.
Since you mentioned Java applets, do you have any experience with Java Micro Edition?
No, a friend of mine tried to write some mobile applications at that time in the beginning of this millennium, but at that time I didn't do it. Yeah, but I think it's dead now.
It is.
So, but basically, when I started on that Android project, that was I started thinking, okay, Java is back actually, because for Android you use Java, but not for long.
And have you tried it to bring it on your project, or now you are on Java 11, or to do something else?
On the current project where I started not long ago, we use Java 17. Again, I already asked about Java 21, but of course the pipelines would have to be adjusted, so it's still in the to-do.
And have you tried to bring the topic about Kotlin?
Not yet. Unfortunately, there are many things that you need to do on a new project. But maybe.
If someone wants to learn Kotlin and haven't worked with Java before, would you recommend them to start with Kotlin right away?
Depends on what you want to do, but yeah, if you can, if you have the freedom to choose what you're going to use for your project, definitely, I think it's great to start with Kotlin. You don't have the baggage of the backward compatibility in Java, and so yeah, go for it. I think. Okay, I think we can wrap it up, and we can still continue talking with beer in our hands.